Okay, I'm your host, Mr. Shindelka. Welcome to Calculus in the PM. Today's topic, the quotient rule. First of all, though, this is a way to do a derivative, and so we should always know what is the definition of a derivative, what's the equation associated with that, and you should be able to say. I'm waiting. Okay. The limit of h approaching 0 on the top, the numerator, f of x plus h minus f of x on the denominator over h. H is on the denominator. What is a derivative? What's an explanation? You should know. I'll wait. Give an explanation. Okay, an explanation of a derivative. A derivative is just a formula that gives you the slope of the tangent line to a given function at a particular point. You need to keep in mind when you use these shortcut rules, the quotient rule, and previously the product rule or the power rule, that every time you're doing that, you're just doing a shortcut for the limit of h approaching 0, f of x plus h minus f of x all over h. Here's the shortcut when you have a rational function, the quotient rule anyways. Now let's just take a look at it and how it's designed. What the heck is this stuff here? There's some squiggles on the board I accidentally have. Okay. So what are we talking about here? We've got a function, a rational function, so we have some expression, a polynomial on the top, and g would represent the polynomial on the bottom. So f is the top expression, g is the bottom expression. Now what is this quotient rule? It's a fraction, and on the top you take the derivative of the top expression and multiply it by the bottom expression left alone. You take the difference, subtract, the top expression written as is, no change, and the derivative of the bottom expression is what the g prime represents. On the denominator, you just square the expression that you started with. Now, for color reasons, I just rewrote it here. Oh, didn't need to grab that there. Anyways, so how does this work? Well, let's do it with an example. Two examples, B and D there, circled on your sheet. So let's give it a shot. So B starts off with, and I'm going to use colors, so I'll rewrite B. F of x equals, as you can see, 2x plus 3 on the top over, which color? X minus 1 on the denominator. Okay, we're going to apply this rule, the quotient rule. And I'll be referring to this set of colors here when I do this rule, because my g expression is in blue, my f expression is in green, top and bottom. So the derivative, we'll use f prime notation. F prime of x is equal to, now here's what I'm doing, the derivative of the top expression, bottom expression left alone. So, what's the derivative of 2x plus 3? It's 2. Times the bottom expression left alone. Subtract the top expression left alone, the derivative of the bottom expression. So, the top expression left alone, 2x plus 3. The derivative of the bottom expression, x minus 1, the derivative is just 1. I'm going to write it down just so you know that I've taken care of it. You wouldn't normally write that down. Okay. All over the bottom squared. X minus 1 squared. Here you have the first step without any simplification of the derivative of the expression. Now, common error. people forget to put this bracket here. And then because of that, their next step might be wrong because they've got to go minus 2x times positive 3, so minus 3. If you don't put the bracket there, you won't be able to distribute properly. So make sure you have a bracket on your second item because this is subtraction. So what does this come out to be? Well, the top, we'll work it out here, is 2x minus 2. I'm distributing the first part of the expression. Then minus 2x minus 3. Don't square the bottom out. Leave it factored. X minus 1 all squared, because that's as simple as it gets. Okay, collect like terms on the numerator. And you will see we've got 2x minus the other 2x, so that disappears. It's really negative 2 minus 3, so negative 5 over x minus 1 squared. Okay, that's the quotient rule. It's actually not that bad. I'll do another one, D. I want to do this one. Sometimes students get messed up because there isn't a polynomial as such. It's a constant on the top, whether that's 1, in this case, 5, or negative 12, or pi. That's why I wanted to take a look at D here. Now, I'll do D. I'll squeeze it in right over here. I'll do the color coding. So D, f of x equals, what did I use on the top? Green. So 1, 2x plus 4. Now, we'll apply the quotient rule. F prime of x is equal to the derivative of the top. The derivative of a constant, any constant, is 0. The derivative of 1 is 0. So we'll put 0 times the bottom expression left alone. Subtracting the top left alone, so 1. I'm only going to write this down just so I can instruct and show you I've taken a look at this step. Times the derivative of the bottom expression. The derivative of 2x plus 4 is just the number 2. All over the bottom squared. Okay. There's a little bit of simplification to do there. So f prime of x is equal to, well, as you can see, that zeroes out. So we're really just left with minus 1 times 2, so negative 2. Guess I won't use that color here. Oh, I know, I accidentally didn't take it off of that. Negative 2 over 2x plus 4 all squared. That'll be fine. You could factor out the 2 and the 2x plus 4. Square it, bring it out, and so on. I'll leave it at this, though. There's a little more you could do. That's just fine. Your turn. This one has a bit more manipulation. So, we'll take a look at it, and then we'll see from there. Show that if f of x equals the root of x over the root of x minus 2. Then, and they tell you what the answer should simplify out to be. So it won't be just your first step. Now, when dealing with radicals, etc., it's easier to do calculus often with writing with rational exponents, fraction exponents, okay? So the first thing I'm going to do for us is rewrite this. I'm not doing any calculus in this step. This is just rewriting using a slightly different notation. So, on the top we have x to the power of 1/2. So that's the same as the square root. On the bottom we have x to the 1/2, make it look like a 1/2, minus 2. Now, let's do some calculus. Eventually, we'll manipulate and get it to this f prime expression here. So, the first thing is, f prime of x is equal to the derivative of the top. Well, the derivative of x to the 1/2 is, remember how this works. Bring this down when I do this here. So I've got the 1/2. X to the 1/2 minus 1 is 1/2 minus 2 out of 2. X to the negative 1/2. Write down the second thing, left as is though. Then subtract the first thing left alone, so x to the 1/2. The derivative of the second thing. I'll put it in a bracket there, and let's just think about it. The blue, x to the 1/2. The derivative, once again, is 1/2 x to the negative 1/2. The minus 2 part zeroes out, so we're done. That's the numerator. Now the denominator, whatever you have, just square it. Leave that as is, don't play around with it. Now, the next thing is to distribute and simplify the top, the numerator's expression. So I'll drop the colors here, but let's just think about this. What is 1/2 this? 1/2 x to the negative 1/2 times x to the positive 1/2. Well, the number is definitely going to be 1/2. X to the negative 1/2 times x to the positive 1/2. Remember, you add your exponents. Negative 1/2 plus positive 1/2 is x to the 0. It's 1. So that's it. 1/2 times 1, we're done this. So then we move it along. Now we're distributing 1/2 x to the negative 1/2 times negative 2, or minus 2. So we've got 2 times minus, or negative 2 times 1/2, so that's minus 1. I'm not going to put the 1 there. You can't, actually. Minus 1, and then x to the negative 1/2. Now, this minus sign here, and multiply these two items. Now, we've already talked about how the x to the positive 1/2, x to the negative 1/2 come out to be x to the 0, so 1. So we're just left with the 1/2 part of the expression, so minus 1/2. Now what? The bottom, just leave as is, it's squared. Okay, there we go. This doesn't quite look like this, what we wanted to, but can you see how the top, the numerator, positive 1/2 minus 1/2, that zeroes out if you wish? Okay. There's negative 1, okay, that's the number 1 with the negative sign in front of it. What does x to the minus 1/2 mean? What does a negative exponent mean? Take the reciprocal. So I'm going to leave this negative 1 on the top. And move this, I put my negative sign in front, sure. Negative 1. X to the negative 1/2, well, first of all, 1/2 means square root. The negative things means, if you want to make that exponent positive, put it to the bottom. So I'm not going to keep this here. But first I say, well, x to the negative 1/2 from here, that really means x to the positive 1/2 on the denominator. I've taken the reciprocal. But I'm not going to keep it as that. I'm going to use the root notation, square root notation. So radical x. Same thing as x to the 1/2, but now it looks more like the expression we're supposed to come up with. And then the square part of it still sits there, except I'm not going to use x to the 1/2, I'm going to use radical x, or square root x, minus 2, all squared. Mission accomplished. Good. That's the same thing. Now, I want you guys to try these assignment questions, 17 through 22. There's the answers. They're in faint blue, so hopefully they printed out fine for you guys. Do your best. If there's any problems, consult someone else in the class. And I will be back on Thursday, so save anything there, but try your best, okay? Over and out.